Good afternoon, everybody. In keeping with the British accent, you've got me for another 20-ish minutes. My name is Neil Glazebrook, and I would like to, and I'm from Limelight. I'm a Director of Product Management, and I'm focused on, in fact, we've built a new practice around edge compute. And for the next 20 minutes or so, I'd like to spend a bit of time talking about the role of edge in content delivery. And before I do that, I'm going to go, before I dive in on that, I'm going to spend a few minutes talking about CDN and just, I think, really highlighting a few of the themes that you've heard throughout the day. Then I'm going to talk a little bit about a topic called edge policy or computed edge policy, which many of you I think would have had some experience if you've got some CDN experience with either Limelight or others in the industry. I'm going to then talk about a new area that we're focused on called function as a service, and then give you a summary and an opportunity to ask some questions. So without further ado, let's dive in. But before I do that, I'm just going to spend 1 minute just making some definitions, because these are going to be used throughout the presentation. So edge compute obviously means different things to different people. And depending on whether you're asking a server manufacturer where the edge is from an edge compute perspective, they'll obviously would be very happy to sell servers and deploy them in the enterprise, in the factory, the workshop, versus edge compute from a telco carrier perspective, or edge compute from a CDN perspective. But I think we will all agree that the definition, the loose definition of edge compute is really processing data as close as possible to the source, whether that's a device or a sensor or something else. Serverless compute is garnering a lot of popularity. We're seeing many organizations launching serverless compute. And it's a bit of a misnomer, because it doesn't mean that there's processing without computers, of course, or servers. But it really means it's offloading the responsibility of infrastructure, of managing operating systems, hardware, networking, so on and so forth. It's really relinquishing that responsibility to the cloud provider. And then function as a service is really an application of serverless computing, and it's where you as the customer is just responsible for creating code, writing functions, and then publishing them to the cloud service provider, and then those functions will scale horizontally and they will run on demand. So they're really the three areas that I'm going to be talking about this afternoon. But before we dive into that, I just wanted to really talk a little bit about the CDN landscape. And I call this my target diagram for obvious reasons. But I think it's really foundational that if you look at many of the CDNs today, global CDNs, many of them have built a foundation around origin storage. Some of them have, a lightweight content delivery platform, aka lightweight OVP. All of them focus on content delivery services. Of course, that's foundational to the business. And then many are then starting to add web acceleration capabilities and security capabilities as well, whether that's DDoS protection at the edge of the network, web application firewall, bot management, the list goes on. But I think one thing that's very common is that they're all using some form of edge compute to do their role. And I think CDNs in general were a great example, an early pioneer of edge compute technology. Almost take it for granted. But anyhow, what I'm going to focus on this afternoon, I think sometimes we forget that if CDN, content delivery service, is truly foundational, I'm going to be focusing on really value-added services on the core delivery services of edge compute policy and then function as a service. So let's talk about edge compute policy. This is a genericized name. Limelight calls it something different. Akamai has some similar capability, and I'm sure many of the other CDNs offer this type of functionality. But if the CDN provides the standard behavior of requests and responses and caching, really computed edge policy is adding a layer of enhancement and specifically some flexibility around how the CDN acts on specific requests, responses, and indeed traffic flows. From Limelight's perspective, we have this built in at the edge of our network, so there's some core functionality, certainly some standard templates that the customer, you, can configure, and then there's a possibility to work with our professional services organization, and again, I know other CDNs have similar functionality, where it's possible to look at a use case and then with policy, in our case, we write these rules using Lua, it's possible then to accommodate some of those use cases around request and response and caching behavior with this custom capability in policies. So one example here on the top, we have a customer that's actually doing this. So let's say a request comes in from a browser for a particular URL. So we would look at that request and we would pass it up from the CDN functionality up to our edge compute, and we would look at policy A, and policy A is making a decision where to route that content request based on a geolocation. And in this instance, we're making a decision whether that customer is going to be served English American language, or whether it's Japanese, or whether it's French. So based on that lookup, the request is routed to a particular origin server. And then in the reverse direction, so the response again goes through a edge compute, and it's routed to policy B. And policy B really involves some caching, very specific caching rules about that piece of content. And there's certain rules that we can invoke there, short-term caching, don't cache, so on and so forth. So again, this is about building on core functionality of the CDN, but really allowing the customer to either A, use standard templates and do some custom behavior, or invoke a services organization to do something more specific. So there are many use cases, and again, we have multiple customers that are taking advantage of computed edge policy. We have many around security, where we might analyze, create, and replace token strings. And we would exercise really granular control for the purposes of security and conditional access. We have another customer in the UK that has two separate content sites, a .com and a sport.com. But they have a URL structure that's the same for both. So we use this engine to discern which origin we're going to be sending the request to, and the caching rules around that piece of content from a CDN cache perspective. So next I'm going to talk about function as a service. And this is really now augmenting, in our case, a digital service with a fully distributed application-based processing layer. A bit of a mouthful. But instead of us, Limelight, providing the templates or offering professional services to create those custom rules, you, the customer, now in a runtime of your choice, Python, JavaScript, Node.js, for example, could create those custom functions and run them at our edge. So those functions, if I again look at the diagram, I've got really two functions that are run here. So both of them are created by you, the customer. They will be published, in our case, to Limelight Object Store. And I've got a red function, A, and blue, a B, the blue function. And then in this particular use case, when a request comes in for a piece of content, it's received by the CDN, and it's passed up to function A. So the publish function is invoked, and it's run in real time, and there's a very thin routing layer that determines whether the origin request, this case is a video request, is for a piece of content that's statically packaged or dynamically packaged. So once that decision is made, function A calls function B, and it retrieves, in this case, a manifest file because it's from a static origin. So there's a manifest file with that, and once it retrieves the manifest, then it could manipulate the conditional access, the token string, for example, for that particular customer based on whether they have subscription, their content rights, etc. So multiple event source types. This could be, in this case, a URL that triggers the function. But equally, it could be an API. Equally, it could be a piece of content in an object store, a metadata that's associated with an object that is changed. So I'm giving you an example of a workflow within a CDN, but this could be completely independent of a CDN. There's very broad utility. So again, if I look at the diagram on the bottom right-hand side, the serverless compute platform is really the underpinning of function as a service. Multiple use cases that you as the customer can define, multiple event sources that I've just described, and functions that you own and you would build. And again, multiple downstream resources. In this case, called an origin server, but these network or service calls could certainly be outside the confines of a CDN. It could be a cloud compute function, S3 bucket, for example. It could be a VPC call to AWS, so on and so forth. So one of the use cases that we've had multiple requests for is image resizing, dynamic image resizing. And this is all about understanding the context of a user request. And by context, I mean which device, what network is that customer coming in over? What format will this content be displayed on? So on and so forth. And this can all be determined with one or multiple functions, and then take a single mezzanine file and then on the fly do that transformation and also the caching rules associated with it once the transformation is complete before delivering it back to the requesting device. Another example might be an event workflow where you want to determine the behavior of a new subscriber or a customer that is not signed up for a service yet versus an existing customer. And you might want that workflow to be different depending on whether they're a new customer without existing customer not signed in, new customer, no subscription, versus existing customer signed in. And again, functions are a great way of discerning different types of behavior depending on context. And then finally, is an area that I'm quite close to in this edge compute role here at Limelight, is IoT, where we have potentially hundreds or thousands of sensors and devices generating voluminous data, huge amounts of data. And function as a service is a great way of performing, that first level of analysis and aggregation before data is sent up to potentially, centralized cloud for analysis. So that first level of, in some cases, a first level of response can be done at the edge where you have the lowest possible latency. Compute is done very, very close to the sources of the data. So in summary, I think the main differences between edge compute policy and function as a service. So from a use case perspective, edge compute policy is usually it usually is an enhancement to a request or response or caching behavior within the confines of a CDN. Versus function as a service, which has a much, much broader range of use cases, and in fact can be CDN independent. The relationship to CDN from a workflow perspective, edge policy typically does not do remote network or service calls. It's in the runtime of the CDN, as a consequence can have quite stringent timeouts, so that you're limit really to how much you can do within that runtime before you're going to get timeout issues. And it's usually triggered within the CDN thread. Versus function as a service, the example I gave you, the request came into the CDN hands off that request to the function, and its work's done. Work is complete. The function takes over, and it can make one or multiple service or network calls. And it has its own runtime and autonomy from the CDN. So it's a lot more flexible. In terms of the functionality, again, core functions, templates provided typically for edge compute policy, a computed edge policy, but really a limited set of use cases, and they tend to be media and CDN centric, with some customization, but you're usually going to be invoking professional services. Versus function as a service, you, the customer, own those functions. You get to choose the runtime. You get to define exactly what that function and microservices that you can string together, and the language, the libraries and everything. That you have that flexibility. And then finally, from an event source perspective, compute edge policy, again, very CDN-centric, and it's usually a URL-triggered event or an API, versus function as a service is, again, rich and varied. It could be API, could be URL, it could be change of a metadata, describing an object in a central store, or many, many different event triggers. So from a formal presentation perspective, that's all the material I have. Be happy to answer any questions that the audience may have at this point. I think I've kept us back on time. Any questions? Okay.